All right, Unit 9 today, because remember we skipped Unit 9, so we're coming back to Unit 9, Topic 1. Okay. Topic 1 is going to be called, we're going to just abbreviate, radicals. And we're going to draw arrows to rationals. I'll explain what it means. All we are doing is rewriting a problem from a radical to a rational. We have to know what those words mean. So we're going to have two different things. We're going to have what's called a radical. And then we're going to have a rational. Okay. A radical. What's another word for a radical? We've already done an entire unit over it. No. Nobody knows what a radical is. This is really, really bad. Not one person can tell me another word for a radical. A square root. Y'all have got to know that. A square root or a radical house. It's the same thing. Same shape. It's not the same thing. It's not going to be a square root anymore. Okay. A rational is a fancy way of saying fractions for today. A rational is basically a fraction. Okay. So we're going to go from roots to fractions and fractions to roots. So when I have a radical, we're going to draw it kind of big so that we can look inside and see everything we need. Okay. And we have a letter inside, like an X. Then there's two things you need to know. Normally, there is no number right here because when you take a square root, how many of the same number do you have to have? 2. So if there's no number, it's automatically 2, a square root. The number that goes right here starts with an I and is called the index. Second, let me rearrange. So this I right here is called the index. And then the X can have an exponent, and we're going to give it the letter P for power, like an exponent to the second power to the fifth power. Okay. Now, this can actually be written a different way, and you have to understand both ways. So I have an or. I can have the radical house with the letter X. My index always stays there. It cannot change. So that's still where my index is, inside the little bitty check mark. Okay. However, the power can be written outside parentheses. I don't care which way you write it, but you have to pay attention. Thank you. You have to pay attention to the problem and know that these are the same thing. Okay. Now, how do I change this to a rational? Meaning I'm going to need a fraction. Well, the X, whatever's inside the radical, will stay the same. It'll stay an X. And then the fraction has to be in a very specific order. Okay. It has to say power over index. So power over index. Okay. Power over index. So there's no really other way to write this. You could use parentheses if you wanted. So if you wanted to write that, we could. We could have the X, but it would still be the same fraction, power over index. Okay. All right, we're going to do a few examples and talk about these, and then you're going to try some on your own. So, example number 1. if I give you 6 to the 2/3. So I gave you a big number, a big base with a fraction. We are going to change it to a radical. So first thing I know is this is going to have a radical. No matter what, it's got to have a radical. That big 6 is going to stay big, but it's going to be inside. Now, it's power over index. So my 2 is a squared. That goes inside, a little power. And then my index is a 3, and it goes right inside that check mark. How else could I write this? Where else could that 2 go? It should go or could go outside. Either one of these, but you need to know they are the same. Okay? Let's talk about another one that looks similar. What if I say x to the 1/2? So first we're going to make a radical. What's my big number or letter going to be? X. What is my power? My power is 1. Do we ever write anything to the first power? No, I'm going to write it just so you see it, that it would go here, but we don't normally write it, okay? What is my index? 2. You don't have to write it either. Why don't you have to write an index of 2? It's automatically what a square root is. Can I write an index of 2? Yes, you can. But the best answer would just say square root of x. Okay. I would give you points, but when you take SAT next week, you're not going to see those numbers in there. Okay. And I can almost guarantee you this is on your SAT next week. So number 3, let's go backwards. Let's talk about, let's see here. Let's say 3 with a root of 5 and a 4. So it starts as a radical. So that means I'm going to have to turn it into something with a fraction, a rational. So what's my big number going to be? 5. And my fraction is power over index. What's my power? So 4 is my power and my index is 3. So 5 to the 4/3. Okay. We're going to do 2 more. Number 4 is going to say a root of 3x to the power of 6. So here's the tricky part. What is my big thing? What is the base going to be? 3x. How do you tell me 3x is a base? How though? How do you tell me they are both part of the base? They're together. How do you group something together in math? So this has to be in parentheses. Here's why. I'm going to show you. Okay. If I just make my fraction, just watch and then I'll let you write down. What would my fraction be? What is my power? 6. And what is my index? 2. Why is it 2? It's automatic 2. There's nothing there. Now, look here at my paper. Don't write. Look. This power, this fraction, is currently only touching what? The x, which means only the x would be in my radical. Is that what this says? So how do you tell me the whole thing is in there? This whole thing has to be in parentheses because that entire term is under the radical, okay? Now, here's the tricky part. 6 over 2 is not my good fraction. Why is that not a good fraction? I can simplify it. So what would this actually turn into? 3x to the power of 3, because 6 divided by 2 is 3. Okay. Questions so far? All right, here's the tricky one. So I really need you paying attention. Okay. So number 5 is going to say 4 to the negative 3/2. What's different about this? It's a negative, okay, in my exponent. That's what matters. So a negative, we're going to write it over here, a negative exponent flips entire answer, and I'll show you what I mean by that. A negative exponent flips the entire answer. So everybody pretend with me. Let's pretend the negative's not there. So if the negative's not there, how would I write this radical? I'd have a radical house. What would go inside? 4. What's my power? 3. And what's my index? 2. Do I write it? No. Okay. Now, that's what happens if it's positive, but it's not positive. So technically, this entire thing can be a fraction. How do I make any number in the world a fraction? Put a 1 under it. Very good, Jerry. Put a 1 under it. Now I have a fraction. Okay. Here's what it says, though. A negative exponent flips the entire answer. So instead of radical over 1, what's my real answer going to be? 1 over my radical. So we need to do another negative. Let's try one more. Okay. All right, last one. So let's do this one. Let's say 2x to the negative 1/3. So first thing, pretend the negative's not there. So everybody on their paper, pretend the negative's not there. If I pretend the negative's not there, what's it going to say? A radical. What's inside? 2x. I like to put it in parentheses. What's my power? 1. Do I write it? No. What's my index? 3. Do I write it? Yes. But that's the positive. So over 1. Now, what happens since it's negative? What's it really going to say? 1 over the cube root of 2x. Questions? Okay, that is all I'm asking you to do today. All I'm asking you to do is rewrite and flip things. I'm not asking you to put anything in a calculator. I'm not asking you to solve anything, okay? So you're going to get this packet. Look up there. What's it say on that packet? So where are you writing? In your notebook. There are 32 questions. I know it sounds like a lot, but I guarantee you probably 90% can get all 32 done because they go very quick. Okay?